There's a rude answer.
I'm trying to. I'll write it in my journal.
Most colleges don't
As long as
teach
it's
you the kind of 2D word anyways.
Yeah, I know.
I mean,
He
you're
want
already-
well
You're already
again.
over
I don't see.
exceeding PDs.
I know, I feel like
He wanted me to teach like the textbook, and I said the textbook exists already. I want to be something other than the textbook, right? I hate the teachers that are walking, talking textbooks, and you ask them a question outside the textbook, they can't answer it. Anyway, all right, I'll let it go. Frozen, all this kind of stuff. All right, so here's section 8.3. So we did this whole little group work thing yesterday. Those of you that weren't here yesterday, I gave you that sheet. So on one side of it, there's these steps of things to do with this data. There's 4 groups of grades at the top. You probably want to try to do that front side on your own at some point. It's really just a review with some weird questions thrown in that had everybody thrown off for a little bit. I was trying to lead everybody in a certain direction. So what we got to was the mean is not enough by itself to know. So let me give you a less numerical example of this, right? Do you guys know that there's a website? I'm sure you guys know about the website Rate My Professors, right? And I remember on the East Coast when everybody first learned about it, the next day all my colleagues had gone in and rated themselves. He's amazing. Somebody wrote, he's the essence of the essence, and all this kind of crap. Gave himself a tamale, whatever. Anyway, there's also a website that you have to pay a little bit of money, but it will show you grade distributions for teachers. Do you know what I mean? So you can go and see, when they taught Math 103 the last 5 times, they gave 50% got A's and 20% got B's. Do you kind of see what I'm saying? So then you can see this other teacher, maybe 50% got F's, and you're like, I think no. Right? Unfortunately, people will gravitate towards the easy A's, and you won't learn shit, but oh well. And then you'll take me, and you'll be angry at me. But again, I'll get over it. So let's say you knew that there are these 2 teachers. You're going to decide between these 2 teachers. Everything else is the same. They even give the same average grade. They give an average of a C. But that's not enough to really make a decision. So what if one teacher gave, let's say you're in university where D's actually are passing. Right here, D sucks. It's not going to transfer, so no way. But once you get to college, you can make D's and still pass. Oh shit, just don't build the bridge. I'm going to go over. Let's say that the one teacher gives from B to D. So an average of a C. And the other teacher gives from A to F. So depending on your situation, so let's say it's a class you know you're going to do well in. Would you take the teacher B to D, or would you take the teacher A to F? Because you want to get that A. And let me tell you, I've lived the experience of getting the highest grade in the class and only getting a B because our teacher said, I don't think anybody here deserves an A. Right? God comes along, takes the class, and he didn't do, oh, well, he got an A minus. Not quite. Anyway, I'll let that go too. Eventually. Does this make sense? So if you know you're going to kick ass in the class, you want the teachers that actually gives A's. If you know you're going to suck in that class, you want to give the teacher that doesn't fail anybody. Does that sort of make sense? So knowing the spread of data gives you an extra dimension of knowing something about the data without having to look at all. I don't want to see all the grades they ever gave. I just want them to give me some information so I can make a decision. So giving you the center and the spread is quite often enough to make a decision about. Okay, maybe. So what we talked about, if you weren't here yesterday, we talked about the mean is not enough information. I need one more piece of information at least. And instead of just telling you where the center is, I also tell you how spread out the data is. So again, if you look at that sheet, I know several of you here yesterday, you can look at Group A through Group D. Group A is not very well spread out, if you look at that sheet. Group D is really much more spread out. So Group A should have a smaller number than Group D. This number, we call it the standard deviation. On average, how much does every data point deviate from the center? That gives me an idea of how spread out the data is. How are we doing? Semi-good. All right. So let's do another example with some data here. Let's see. Let's use this data here. What you got, Jeff? I don't know, man. Let's see. 6. Make it come out nice. Yeah, okay. Trying to make it come out decent. But we'll see what happens. Alright, so here's the idea. The idea is actually, I really want you to understand this idea of spread is kind of a neat, higher level kind of idea, and you can use it in all these theorems and do all this stuff with it. The work that goes into it is not high level at all. Subtractions and squaring and right? It's got that symbol we've talked about, this symbol in it, but we know what that means now. It's just a short way of saying sum up all the stuff that comes after this symbol, right? So the first thing I want to do, if I'm trying to get an idea of how far away the data points get away from the center, I'm going to see, well, how far each one from the center. So first off, you guys help me out. What's the sum of these? What's the sum of x? I'm going to mimic that back of that handout. What is the sum of these? What's the sum up to be? Yeah, I think it's 90, 10, 20, 30, 50, 70, 5, 80, 90. Good. So what's the mean going to be? Good. You guys with me? Is this cool? You know the mean means average, and you came into this class knowing how to calculate the average. The thing you didn't know was what it looks like in Mathish. That's what the average looks like in Mathish. Add them all up and divide by how many there are. I'd rather write this. So if I add them all up, you get 90. And how many other? 5. So the mean comes out to be 18. 11. All right, let me stop there for a second. You guys okay? You guys with me? All right. Are you guys bored? Maybe? No? No. Okay, good. Bored is bad.
My mind is processing all that traffic I just went through.
I'm glad you made it, Maury. I got your email, so I'll just try to let you be.
Yeah, for a second I was like, I thought I was driving to the campus, not to LA.
Yeah, some days. All it takes is a little rain and people freak out. So what would I put here then? What does this mean? This means take that data point minus the mean. So 12 minus 18? Negative 6. What about here? Negative 3. What's 18 minus 18? 0. 3. I didn't do that on purpose, but I just noticed it came out symmetric again. Damn, I wanted to show you an example of one that wasn't. But too bad, oh well. So again, these are going to sum up to be 0 always. So this column here is a not useful column at all. It's just sort of telling you you're on the right track. If you add them up and you get 20, you did something wrong. You got the wrong mean, because the mean should have equal amounts negative and equal amounts positive when you take the differences. The mean should be right in the middle of all the values. All right, good, do good. And then the next thing I do, because here's the formula. Let me put the formula up here. Oh yeah, that looks beautiful. Sorry. So what does this need? I need to sum these up. So I need those before I can add them up. So if you cover the sum symbol, you know what you need a bunch of, so that you're then able to add those up. So how do I get those? Well, I've already got x minus x bar, so I just have to square it. Do you guys see that? Do you guys see that? Do you guys see that? If I saw this in an equation somewhere, let me do this. If I saw that in an equation somewhere, I'm not saying you will, but if I did, who could tell me what kind of columns I would need to make? What column do I need before I can add them up? I need a column of so here's my x's. And then maybe I could do x minus 3, right? Just get it started. And then what would the next column be? Yeah. Divide by 7. And whatever I get at the end, whatever I sum them, whatever I get here, I add them up, and that's what this is. That's what the whole thing is. Add those up. Replace the whole thing with the number that is it. So in this equation, this is one variable. That is one thing, and you're going to replace the whole thing with a number. What number? The sum of all these things. That summation symbol gives people a lot of trouble anywhere. But statistics is sometimes the first time people see it. So it's kind of nice if you're going to take stats, you're getting a little preview. It's kind of nice. And we're not going to do too much funky shit. This is the funkiest thing we're going to do with it. The stats will go a little bit funkier. But so what do I put here then?
36.
Yeah, negative 6 squared, 36. 9. So when I add those up, what do I get? The sum of x minus x bar squared. What do I get? Niftily enough, I get, I can't take credit for this, but you get 90. All right. It's complete coincidence. Complete coincidence. You with me? Man, I made a really weird set of data just out of nowhere. All right. You guys still with me a little bit? Yes, ma'am.
I was surprised. I knew how to do all of it, but I got to 38 and I couldn't do that with it.
38?
In the book.
Oh, in the book. All right.
Because it was, they weren't even numbers. Everybody did something wrong.
Oh, yeah, those numbers are unfortunately, again, I didn't mean to do this, but I picked a symmetric set. So if this would have been 11, this would have been negative 7. Right? And then maybe I could have made that 19. It would still have the same sun then, right? Because if that was 11, this could be 19. And then this would have been 1. So negative 7, negative 3 would have been negative 10. 1, 3, and 6 is positive 10. So it doesn't have to be symmetric. It doesn't have to have a positive negative. It's just the crazy way I did this purely accidentally. I figured if I just do it without thinking, I will get something that's not symmetric. Oh, Jeff. Damn. Maybe. So now, so you do the exact same thing. I don't care what numbers are here. You do this. And what's the most important thing up here is that the idea makes sense. You're so programmed in math and early parts of math to think, here's an equation, I plug shit into it, and I get a number, and I go to the next one. I mean, this is true in one sense, but especially in statistics, we took math and we said, math, give me something that tells me what I want, and math's over there. All right, man. So it gave us this. Because why is this what we want? Because I'm adding up the things I want to know the average of and dividing by about how many there are, right? We talked about this little weirdness. When I add something up and divide by how many there are, I'm going to get the average of that. And what do I want this number to be? The average distance from the middle. So I'm going to add a bunch of distances from the middle up and divide by how many there are. Okay, good. Never lose sight of that. This totally makes sense. That's why the number makes sense of what it wanted to say. So how do I write this down? S equals the square root. What do I put here? 90. 5 minus 1. Square root of 22.5 is like 4.68. Better. I made it up after 4. Do you guys, can somebody do that for me? Anybody have a calculator?
4.7434.
Oh, that's pretty close. 4.7434. Right? So what does that number mean that we just got? What does it mean? So here's the middle, right? That's the middle. So what does that number mean? Yeah, on average, the data points get that far away from the middle. Right? This is how far away? 6, this is 3 away. This is 3, this is 6, this is 0 away. Right, so it's a rough the squaring doesn't make it exactly perfect, but we had to square to kill the negatives. But still, it gives a rough idea of how far away on average the data points get. Maybe.
I do want to put an uneven number.
Okay, all right. We'll do one more. I agree. I was trying to make the mean come out nice, and then I made the numbers too nice. So let me see. Let's do a short one, real short one. Let's do 4 depth ones. 90, 112, 147, and 349. Let's make it 211. Let's see what happens. Let's see what I did. Let's see if Jeff's brain is working this morning. Oh, I put money on no, just because. A little bit of a headache going on, but we'll see if my calculator in my brain is working. So this is the data you got. Whatever this data represents. Could be anything, right? So the first thing you do is you see since you want to know the average distance, you figure out what are the distances for everything first. That kind of makes sense. So first off, the very first thing I have to do is what? I don't know what yet. What do I need to know before I can do this?
The mean.
The mean. So I see some people already working. I like that. So when you add these up, what do you get? 560. Oh, good, I did it. Yay, Jeff. And then it's evenly divisible by 4. 1/4. You can do it, Jeff. 560 divided by 4. 140. Is that cool? Is everybody with me so far? Okay. So that's the average of these. Why does that make sense? What would you tell somebody if they got an average of 93? How could you explain to them very quickly that must be wrong? Why would an average of 93 not make any sense?
Too low.
It's way too low. I mean, there's 93 is here, and there's all these that are higher. It's got to be pulled up higher. And, obviously, if you got 72 as an average, okay, crap, what the hell? It's lower than all the data points. How can that be the average of these? Or, 280. Are you guys kind of with me? At least take a second to make sure that it looks to be somewhere in the middle of all the values, right? It's not the median, but still. Yes, ma'am?
So does it need to be divisible by 4? Or is that just to make it pretty?
Well, I was just trying to make the mean come out nice.
Okay.
Most of the time I'm going to make that happen because I don't want the decimals to be the reason that you get mistakes. I mean, the concept is already difficult enough. In statistics, you're going to get whatever the hell happens. Okay. So let's see, what do we get here? So now we know the mean is 140. So what's 90 minus 140? Yeah, there. Negative 50. 112 minus 140. Negative 28. 147 minus 140 is, remarkably enough, 7. And then 211 minus 140. Now, is there positive 50? No, but negative 50 minus 28 is negative 78. 7 and 71 is positive 78, so those add up to be 0. So I don't care what. The mean is always going to be in the middle of the values. There will always be equal amounts negative as there are positive. There could be 18 positive ones, but then one really big negative one. To make it all come out to be 0 at the end. That's what the mean does. Maybe. Whoop. So that's a good check. This has always got to be 0 or close to it. Why would it be close to it? If I did have decimals and I was rounding, maybe it wouldn't be perfect because I rounded. But here we got whole numbers. It's got to be 0. All right. And then, of course, what do we do with these? Square them so that I get that number, the sum of them I can put into the equation. I like it. Kick ass. want to check in with you guys. How many of you guys are taking stats next? Anybody? Nobody? What are you doing in here?
That's 102.
I'm sorry, 120. How many are taking 120? Math 120. How many are taking math 160? Maybe I should say it like that. Okay. That's statistics, math 160. And the rest of you are interesting people. I'm not sure what your plan is. You got to take something after this to have it mean anything, to be honest. This is not transferable, this course. You got to take one more course to be transferable.
Is 160 easier than 120?
120, I love teaching 120 because I teach my students, we talk about logic, like if-then stuff. We talk about Fibonacci sequence. We talk like we did a little bit. We talk about a little bit more. We talk about Babylonian numbers, Mayan numbers. We do all this weird nifty shit. It's just, I call it fall through the cracks math because it's math that you could have done earlier, but there just was no time. So 120 is a beautiful little course. It kind of shows you that math is not just algebra. Math is well beyond algebra. Algebra is just one piece of math. Statistics is the one that's a more useful, I'd say. 120 is beautiful. 160 is useful because we all see statistics every day. And you have to know how to interpret it to make any sense of it.
Yeah.
Do you see what I'm saying?
Mm-hmm.
160 is not easy, but it's also not hard. There's barely any algebra in it. It uses formulas, but you don't actually have to manipulate those formulas much. A little bit you do. Does that kind of make sense?
Yeah.
So statistics is remarkably useful. A lot of majors require statistics. Funnily enough, mathematics is not one of them. It's an elective. Statistics is an elective for math majors. Yeah, exactly. Good reaction. Someday we'll get it to be correct. All right. So here, what's 50 squared? 2,500. I like it. 28 squared?
74.
784. So you said 784? Okay, I was saying 74. I was like, oh crap. 7 squared. I think 71 squared. 49, 5,041. Real quick. I'm sorry. You guys want to know how I did that? That's right? Before I go further, before I show off, I'm like, please do it. 71 is 70 plus 1. That's remarkable, right? So 71 times 71 is 70 plus 1 times 70 plus 1. 4,900 plus 70 plus 1. Bam! Ooh, it's amazing. I'm not a human calculator, though. I don't want to devote brain space to that bullshit, but calculators exist. But this kind of thing is neat to be able to do in your head real quick. All right. So I've used up all my brain power. Add those up for me. But it's all about. It's like 8,370. What is it?
8,374.
Yeah, I got close. Let's just lost the last digit. All right, how are we doing so far? Again, the math involved here is really not hefty at all. Because the concept is already weird enough on its own. It's not even that weird of a concept, but what is this exactly? What symbol can I use here for this? What did we just do? What does this mean? Yeah, it's these, but what did I do with them? I added them up. So anywhere I see this in an equation, I can put this in place of it. So in my equation, yeah, there's screwed. I got that on top. So now I can put that number, 8374. Don't square it, right? The sum of these squared is that. The whole thing gets replaced with 8374. Do you guys see that? That is a different thing for algebra students. Yeah, I like it. And of course, n here was 4, so now I'm divided by 3. It's not divisible by 3, but oh well. So 100, 10, 330 times square root of 3, I don't know. Shit. So what do you get there?
2.91
When you divide by 3, right? But have you square rooted yet?
Oh, no.
Okay. I love you guys. Anybody bring their calculator today?
2791.3 repeating.
All right, now do a square root of that for me. All right.
52.83
Now that standard deviation is a lot bigger than the one we just calculated earlier, right? Because those numbers were much closer. They were all like 3 away from each other. So how far away from the middle were they? Came up to be 4 point whatever. Here, there's a much bigger spread amongst all the numbers, right? So they are further away from the middle. In fact, on average, they get about 52 away from the middle. That's what that means. So if I told you the average was 140, and the standard deviation is 52.833, then you have an idea of how far they get. So if I told you the average was 140, and the standard deviation is 2, give me some data values that would make sense. I like that question. If the average was 140, and the standard deviation was 2, give me some data values that might be in that set of data.
148.
Okay, 148 could be, sure. Something closer to 140, like maybe 142, 139, 135. It's not going to get very far away from the center because the standard deviation is so small. This one, they can get pretty far away from the center. Standard deviation is 50. I like it. Sort of. No? What's up?
Maybe I figured out.
So
What I was saying in terms of when we get a little bit more clear, if your means turn out to be like 54 and 58, right? You got to have an exact number. So you know how you're supposed to come to 0, right?
well, like I said, if you round, you don't have to have a whole number. You could use the decimal in your x minus x bar. You could use the decimal in there for sure. No problem.
But I still need to get to 0. If I can't get
If
to
you
0,
round at all,
okay.
it won't come out to perfectly 0.
Oh, okay.
It'll be a little bit negative or a little bit positive, but it ain't going to be more than like 1 away in either direction. Shouldn't be.
There you go.
If you
All right.
round. Yeah.
Fine.
If you get 20 or negative 18, that's too much. You made a mistake.
Okay.
I like it. So if you round at all, it's not going to add to be perfectly 0 because you kind of threw it off a little bit.
Gotcha.
I like it. Sweet. That's the kind of clearing up that I enjoy. Because that's not a misunderstanding. That's just what the hell happens here. Okay. Okay. Cool. So that is enough of that. We're going to do some new stuff today, and we're actually taking a big old step back to chapter 2. I know. There's a method to my madness. Somewhat. So, I mean, we've got a formula here that we're just throwing stuff into. And now I want to come back and remind us, okay, there's stuff we can do beyond that. We can have formulas and functions and equations that I could solve, right? So that's a different idea. It's not really an equation to solve, it's a formula to use. So we're going to take a step back now to chapter 2 and do some solving equations. I know some of us are completely fine with solving really freaky looking equations, and some of us probably are like, what the hell are you talking about? I've got a little handout I'm going to give you here in a minute, but the first place we have to start when we're talking about solving equations is doing stuff like this. Like terms. Is this dude still going? Poor little dude. Oh, you're about to stop. Good.